Okay, so let's just look at our exercise. I know the lab right here says create a new first-person project. Let me actually just edit this. We actually you don't need to. You should be able to continue this using. Let's see what this exercise too, but yeah, just complete the following exercises. You won't need to make a new project for this week. Save this. Okay. So there's two exercises. First one is you need a new project. Your existing one started content. Because basically you're going to need props and you need materials. You're going to make a classical material changer, and basically it's going to have basically two arrays. Yeah, basically it's going to set a timer by event. So this is like you've done a timer by function. This is a timer by event now, and basically you're gonna have an event called change material, and basically you're gonna go through the array of right now it's showing the array how to do this. Has two materials in this case, but basically it's going to have you go through each item in the array. This is weird. Using a flip. Oh, I see why it's using flip flop. Basically, you're gonna go through the array with the for each loop. You'll grab a static each static mesh, and you'll set the material to it. Do I have extra credit? Yeah, I think this is designed for you to use the flip flop. So every time you call this, it's gonna flip between A and B. And I think you can add pins effectively. We'll look at the flip flop during today's lecture. Um, Extra credit if you use two arrays and use two for loops effectively. Um, or you advance actually use two for loops actually, not two for loops. Two arrays, one for loop for each because you're going to go through the array each time. You'll need an index to basically advance through the other, the list of materials each time you go through. It's flipping it about every 2 seconds. So that's your first time. We'll do that in lecture during the lecture at some point. And then your second exercise. The idea here is that you have an event on another event. Trigger detonation. Okay, you're in the level blueprint. We're going to use level blueprint to call this new event that we call detonate, which will essentially basically set the spawn actor in the explosion. So let's go through. Let me do this pretty quickly. Let's get through these slides. So flow control. You've seen the gate node. So basically, think the gate is either you can enter it, exit. Is it open, close, or toggle? So door controls in a simple nutshell. If it's open, you can set it open. The control will flow through here. You can set it close. It will flow through here. Otherwise, toggle will flip it on and off, and you can set what it's toggled. So here's a tick control where basically every tick is doing something, and then as a begin overlap, it starts it, and end overlap ends it. And this is doing some sort of damage based on the overlap. Multi-gate, same idea, except what is going on? It's going to go through 1, then go through 0 and go back, and then if loop is on, we'll loop back around. You can reset it. You can click if it's random, so it picks one of the gates by random, and where to start. Do once. Basically, after the first, it will do this for the first time, and then it will complete, and then it'll be closed. This is good if you're seeing like multiple things happening on the same frame. This node is going to be useful. In fact, later on in our collection game, we're going to need to use this to actually fix a problem. You can reset it, and then you can start close. So begin overlap. We only want to do this only once. And it spawns the effect. And then prepare detonator. So basically, this is setting an explosion. So we can call prepare detonator, resets it. It starts closed. Then we can prepare it, reset it, opens it up. And when this event gets called, the explosion happens. Do n. This is like the do once, except you can do it at several number of times. You can get the counter off of this as well. So after you've done n number of times, it stops until you reset. So here's the R key. It will basically do these 3 times until basically if the other actor is the weapon recharger. So basically what they're asking is this is not how you would do this per se. This is kind of flip design. This is the actors asking if I overlap with something else. The other item would basically say if I was overlapped with an actor, do something. Tells the actor to do something. So, but this is a hey, I'm gonna flip weapon powers 1, 2 until I get to a recharge point. Flip flop again. It's gonna flip between A and B, which we just saw, and you'll know a Boolean whether it is A or if it's B. Here's spacebar, which is basically flipping the visibility of this shield item. Sequence. So basically, it's going to do 1, then 2, and then it'll continue in that order. And I believe it should loop. No, my apologies. It's a sequence. It's going to do 1, and it's going to do 0, then 1, then 2. So basically, it is doing 1, then 0, then 1, then 2. So essentially, the idea is that this is to, rather than being one big line, you can do go off. This is the 0 line. It'll do that. When that's done, it will do 1. When that's done, it will then do 2. For each. So again, this is the idea is that you have an array, and this is going to go loop through each thing. There's this loop body right here. So this is what you'll do on the for each loop. So think each item that's in the array, this will get called. This will be the element that you'll be getting out of the array. The index, if you need to know where that is. And when you're done, it will call this down here. Switch on integer. So basically it is give it switch. There's a number you'll again, this is you'll see this with a lot of switches. So this is a switch based on an integer. You can do a switch based on floats. You can do switch based on strings. Here's switch on string, where you basically give the different names. Now this right here, you would probably end up doing enum instead. Did we talk about? Yeah, we talked about enum. So basically, mesh type enum. So basically, capsule, cube, cone. These are the values of the enum. We'll go over enum in one moment. So on begin play, it is doing setting static mesh on an object based on this value we're doing here. But these are the 3 values of the enum we're looking at. We'll use the enum more in the next few coming weeks. Enum is used basically 2 basic ways you're going to use the enum. Like application states is probably going to be an enum. Some AI is going to use enums as well, control the states of different things. So a lot of state-based things are going to use enum in their programming. Not always the best way in terms of state-based programming, but it's the low, like it's the easiest, fastest way to set up a state machine. So, string and text, you can format text. It takes parameters. I don't use the format text. What I'll use instead is the append mode, and so I'll put. Let me see. Does it showing? Yeah, here is its basic result. Player 1 name equal player 1 score times player 2 name equals player 2 score. So Romero is equal to 17 times Luke equal 14. It doesn't make very much sense. But basically, it's the uses the names of the variables in there. I would have gone and built this with an append instead. Here's the append node. This is like makes more sense for me. And this is old school C formatting, where this is more how I would basically build things. This is like string, like if those are writing in C or C#, C++, you can do some string appendages with the plus sign. So here is hello player name, and there's a space in there for your reference. And then basically append, you can add pins so you can get multiple things. I think I'll set up an append in one moment. String and integer node. You've seen these already. These nodes right here, which are converting from one type to another. So it's taking this string and trying to convert it into an integer in this case. Math expression node. We've seen some of these already. Well, actually, this is a node where you can actually set up an equation. So x plus y is the equation here. Here's x, here's y, taking floats. And here is a math node. I'll be honest with you. Don't use this is kind of works. I mean, it does its job, but ultimately, write a function instead. Like this calculate. I mean, actually we're in the calculate attack damage. This is probably okay where you can use it. I don't use it very often, so just give you a heads up. It's there. You can use it, but keep it isolated to a single spot. And again, they've created an event here instead, a function. Lerp node. So the idea behind lerp is that based on value A and value B, you're finding a middle point based on a percentage, which is referred to as the alpha. The door that we did, we could have done with a lerp. Now, we didn't need to because we could have done a lerp instead. So the percentage, but we didn't because we knew the start position, which is the A, and we were moving only down on one axis. So we were multiplying by that alpha, the percentage, times basically this is what we were doing in the door, the lerp function could have done for us. So this is like our value on the y, our starting y value. The slide distance would have been b, would have been a plus b. Would have been our start position on the y. B would have been the start position plus the lerp value. The slide value, and the alpha would have been the percentage we would have put in, and that would have been on the return value, which is the new y of that. Again, here right now, I don't know race X position, but basically this is basically race how far along the race position is. 0%, 0 would have given you a 1500. The 1 would have given you the 95. Any value in between, you would get in the lerp value. That's basically, think of it as A plus B minus A times the alpha value. Essentially what the lerp function essentially is behind the scenes. Alpha is always going to be somewhat between 0 and 1. It's a float, so it will be, you can give it a 0, you can give it a 1, you can give it any float value between those two values as well. So 0.5 would have given you 1500. So let's do the math quickly. 9,500 minus 1,500 is 800. 80,000. Sorry, 8,000 multiplied by 0.5. That's 4,000. Add 1,500 back to it, gives us our 1,500 value. This is just for let's keep going. Random numbers. So you will get random number in range, random integer, random number in float, random number within range. So random float, random integer. You can get a single random float. I think this is going to return between, integer is going to be between 0 and the max value of integer is -1. Range is going to be between the min and max. Again, good to know that this is here. You will eventually be using these on a regular basis. So there's the idea of a random stream variable, and you create a variable type of random stream. You set the initial seed property in the value section in the details panel for it. Value of the initial seed property will define the sequence of the random number. So if the idea behind a stream is that you're not just calling random numbers willy-nilly into the void. You can call from a particular stream, and this will help make things repeatable for you. So every time this gets called, it's calling up from a stream of numbers, as opposed to being called like fully. This will, again, the idea here is that we're going to call from a stream of numbers because we want this to be repeatable in some way. We want random numbers, but we want it in a random particular way. Again, the idea is that there's an initial seed that we can control that seed. So world generation, random, like Minecraft world generation. The seed that you give it is the random stream variable. The default value will be set to whatever key you gave to that world number for generation. You're going to pass into the random stream variable as its default value. Get into blueprint communication. Direct blueprint communication. First one is basically making variables and make them instance editable. So in the editor, you can again, they have a material display variable of material display instance. Hooray! We've created this of this type. More useful actors. We made a variable of a type actor. We did this like last week. We made the array. We made it instance editable. Functions, we made them public, which makes them basically we can call them from outside of the blueprint class, so other classes can call it. So again, here is that material display variable being used. So this stat, the static, we're getting the static mesh component and doing some set material on it. Casting and blueprints. And we've seen this already. The idea that on a regular basis we are getting a class of its parent, so like an actor or pawn or even controller or character to a certain extent, and we need it in the class that we need it specifically that we want. And again, cast to give it the object. Again, here when the cast succeeds, when the cast fails, and when we succeeds, the new character as again, in this case, we're going from an object reference to a first person character. So again, you give it let's say again, we give this an object, we give it a pawn that's not off the first person character. Let's say we give it the third person character for some reason. That would fail, and we could know that it failed off here. And this is useful to know, hey, I've touched something that's not what I'm looking for. Why you would do this on a regular basis is that we're going to call, again, character goes into that we have our, let's call it the application character class, goes into a volume. Volumes first thing you ask, is it my application character class, because it's calling a function on that character. And that could be in a good setup way that node is then telling, hey, our application character class, add this ability, which is something that it's a adds to an array of things that it has being affected by, and that change stats for some reason. And when we leave that we then tell that object then says take off that ability now. I'm gonna just move through this because we've done casting multiple times. Here is the other, basically event overlap. Here's the other actor, cast to machine. Here's the object, and here's as machine is going to call, again, if it's the machine, then it's calling this recharge function. Again, here's actor. The idea is that you get an actor of reference. You only get what is its variables and functions. Let me bring this over just a little bit. Machine reference allows you, because it's a type actor, you get everything that's in the actor class as well as the machine class. Again, the idea here is that machine inherits from actor, so it gets all the variables and functions inside of actor and then extends it with its own things. And this is the basic inheritance in a nutshell. A great example that we will use, again, I brought this up in 2 weeks. We're going to basically build a collection game, and we're going to build a collectible class, and that will be that will inherit off of actor, and then we will then inherit off of the collectible class to create multiple other collectible items that will do other things. And I know there is. It's not this week. One of the weeks we're gonna build an interactable class where we'll run around. We'll basically use a ray trace to and when we'll hit like E on our character, and it will activate basically a ray trace, and it will ask, did I hit an object with that ray trace? And if that ray trace works, does hit something, the first thing we then ask the object, are you of the interactable class? And if it does, then we call a function on it on perform interact. So we'll talk more about inheritance and in that particular. Again, we'll go over that more time. We will be using overrides because that interact class will basically just say I've been interacted with, and that's all it does. And then we'll make multiple children that do several different things. And that right there will show you that is an interesting lab because that one little system right there gives you tons of different interactions that you can then build from from that example. And again, one of the things we'll build from that will be an elevator. So used for the lerp function. Level improvement communication, we've done this. You can create reference to items into the scene. So on begin overlap, again, we can toggle visibility of the light. And then event dispatchers. So this is what we're going to use. Types of communication between a blueprint class and a level blueprint. This is be. What's the best way to put this? Be generous with this. There's probably, again, we're showing it to you and we're going to use it this week. But ultimately, there will probably be other ways you might want to build things. Depending on, like, don't think this is the first way. This is between the level blueprint. This is between a blueprint class and the level blueprint itself. So, think of this as things that are going to be level specific. And even still, you might build this differently. You might build this different. And in fact, I might have you build this differently. I might actually go back and look at the document. That second half, we'll do the events dispatcher, but we'll look at it in a different way as well, which might make more sense for you. So here is enter call button press, and then in level blueprint you will add an event based on the event for the BB button. So so basically we've created a class called BB button. It has an event called button press, and we're calling that function. And that's what this event is not showing, is that there's another event dispatcher created. In the level event, we then are calling that button press, and then this is the event based on that item. Bind event nodes. The object is going to read. This is basically, you can bind, basically bind one event to another event, or to an event dispatcher. So this case, this is bind an event to when on click is called, bind an event when any take damage is called. So this is hey, bind this event when this gets called, call this event. Here is the create item. Yeah, there's a what? Take a look at this. So on destroyed, so when an object is removed, it's calling this remove item event, which is basically counting down the items. So basically, this is taking up item spawned, and then it's binding an event to the object. Not necessarily how you would do this per se. I mean, this works. I mean, this works. Wouldn't be very specific as like remove item. This is basically doing an inline right here. So, blueprint interface. We're gonna go over this just briefly. The idea is that you can inherit from an interface, and the idea is that it's a piece of code. And it does a particular thing. Think of it like a component. Basically it's a code component. Basically, defines the definition of functions but no implementation. The idea is that, again, if you're building like a health system, the interface defines the functions that you would interface with that system. Now we'll back up. There is actually a damage system in Unreal, so we'll keep in mind. I'm using that. But the idea is that it defines a set of functions, but don't implement them. And basically, when another class says that they implement this interface, they will have those functions defined. So again, a damage system. A wall acts in one particular way, where a character acts in a different way. Um, Another class just is just counting up the damage it takes and does nothing else. So here's an interface. Basically, has turn on, turn off, and it has two functions: turn on and turn off on it. And when you go implement that interface, basically, these functions get added to that class automatically for you to implement. Under class details, the class settings, there is a section for interfaces. So, and there's BP interface, turn on, turn off. You can inherit interfaces. So again, the class that we built here, if we made a child of that class, that interface will be inherited. And hopefully that the implementation is probably inherited as well. But we can also override it, which is now we're getting deeper into object-oriented programming right now. These are all things you can do. This a lot of these slides are, hey, here are things you can do, and as you move on, you will see that this is stuff that you are doing. Basically, function of blueprint, have an output parameter. Again, this is basically implementing the functions, not just pretty straightforward. There's some utility functions. Get all actors with interface. So we can ask for all the actors of a class. We can ask all actors with a particular interface that are in the level. We can also ask, does this object implement this particular interface? So think of this as sort of like it's a pseudocast. What is the object? What is the interface? Does this return? Does it implement that interface? And if so, we can call things based on the interface. That's basically what this is doing. We can get all the actors with the interface, and then we get all the actors out of here, and we can then do a for loop and call, hey, do this particular function because an event has been called. All right. Let's jump into. Let's do a new level. Basic and file save all. Current level. So make a lab 5 folder and just basically call this lab 05. All right. Let's look at that material changer class. So let's go to our content draw. Let's just jump into lab 5 and let's create. It's gonna be an actor. So this is gonna be. Okay, I'm gonna do two classes here. I'm gonna do these 2 different ways. All right. In both cases, first thing I'm going to do is basically I'm going to get basically a. I'm just gonna put a cone. And I'm just going to move this up 50 so it's standing on the ground. I'm basically going to give this hex material because why not? And that is going to allow us to basically drop this into the world. And that's the first thing that we really want, is to be able to drop this into the world. I'm going to put this at negative, do negative 1,000. Okay. For this, basically what I want, I'm going to go to my starter content, and I'm going to go to props, not props. Go back. Sorry, shapes. There we go. Make this a little bit smaller. And I'm going to put in what are you doing? Okay, cone, cylinder, and a wedge. Just so that I'm here. Let's go put in whatever the capsule, the wide capsule, and the tri-pyramid. There we go. Let's grab these and put these in a line to make sense. Build that over one. Okay. All right, let's jump back to our material changer A. So the first thing, these props, just to note that these are static. These are actors with a static mesh component. So basically what we're going to do in here is basically we're just going to ask. So the first thing that we'll want for our variables is going to be the mesh actor list. And we're just going to ask for an actor. And then we'll change that here to the array. And it will be instance editable. Let's go back. Let's give it a category. And we'll call this the mesh changer. So I'm just going to add 3, lock this down for right now. So I want the wedge A. Actually, I want to do wedge A down here first. This will be the cone. And then the cylinder will be here. All right. A is going to use the flip-flop. It'll be between two materials. So I'm going to go to my content draw and go to my materials. It's not the material folder. There we go. And for the sake of argument, we are going to start. We'll leave them blank as it is. So let's go back to material changer A. I'm just going to create material A. This is going to be of type of material. It's going to be a single as opposed to an array. We'll create another material, and this is going to be material B. Instant editable, so we can set those in the editor. And where are the materials there? I didn't set them to, let's put these in here. So there we go. That makes more sense now. And I will just say this will be rust and use gold. So we'll be flipping between those two materials. One thing just to make our lives easier, we'll add one more variable. This is call it change time. We'll set this to be a float. And we'll set the value to be 1.5 seconds. I did two. There's two in the basically, and we'll make this also instant editable so that we'll compile. We can go back, and hey, again, we need to add that to there. Compile. So again, here is section. So again, we can now change that in the editor as we see fit. You know, we can go from 1.5, we can go to 0.5. So now that we've done that, we can go to our event graph. We won't need event overlap. We won't need event tick. I think they're going to set us up with an event. So we can go and create a new excuse me. There we go. Add custom event. There we go. So this is going to be change materials. All right. The first thing that it really wants here is the flip flop. For our purposes right now, I'm going to make our lives a little bit easier here. I mean, if it's A or B, it's basically what we're going to do. What you're then going to do is, I'm going to do a reroute node. A and B are basically going to the same spot, which is then basically a for each. We're going to get the array of the mesh actor list. Just to the sake of argument right here, promote to a variable. I think, yeah, this is not. It's not going to be a. We'll leave that for right now. Yeah, we'll set it this way. Heck, just to make our lives easier in the moment right here. We can delete that and actually go. I'm doing this because ultimately what we need to do on the other side is to use this variable. It's going to make the loop body easier to Dan. So array element, what we want to get is it's going to give us the, so again, the array is type actor, so we want to get the static get. Let me look at this scene one more time. Okay. So note that they came in as static mesh actors. So let's go and just to take argument, let's do a cast. So if the array element cast to static mesh actor. And if failed, we'll just say print let's drop this down here. We will cross the streams for one moment. We'll use the append. So we will grab the array element and get Where's actor name? There we go. Get object name. We'll just say is not ace. Okay. So this is what we're doing if this fails. I'll crunch it up right here because what could I have done instead? Instead of having an array of actors, what class should I? Anyone want to make a? Gentlemen, anyone want to make a guess? What class I should be? I could have used the array. Anyone? Are we paying attention? No. Okay. So what I could have done is that I could have set the array to static mesh actors. And that would have taken out the need to do this casting right here. All right. So based on the static mesh actor, this is where I'm going to get the static mesh component. And here I can then set the material. Now there's going to be one more step here. This is going to be the if. Again, I'm bringing the is a. Drop this down here. This will be the target. So true is going to go up. Again, this is a little convoluted at the moment. Material index. Again, this is what material. If the object has multiple materials, that's what we want. But ultimately, here is material A. Get material B. Get. And then this is basically on begin play. This is again set timer by event. The event in this case is going to be the change materials. And again, our change time is going to just plug it there. We could hard code it, but I would rather you not hard code it. So this is convoluted because we got the flip flop going on. We set it as static mesh actor. We're going to do this again. So let's just, for the sake of argument, let's compile this. We should be able to go back into level. Again, we've set these here. We press play. You can see that these are being and what I forgot to do one thing is I forgot to make it loop it. All right. Where is my okay, so for the sake of convenience, I'm going to pull this a little bit closer, grab all of these, and I'm going to move these from behind us to, come on. There we go. So we'll move these up over here so we can see them. Now you can see it's now looping back and forth between the materials. All right, so that was a bit convoluted in terms of how we built things. And it's not necessarily you would actually build it. So let's look at the better version of this now. Again, we would then basically start with, just put in a cone. give this the hex material. We're basically, in this case, we're going to create three variables. This is going to be the mesh list, material list, and this is going to be the mat index, material index. This will be essentially a integer. This will be a list of materials, and then I'm actually going to go do static mesh actor. Make this an array. It's iterable. This will be an array. This will also be instant editable. The index won't be, because essentially that's going to be it. Start at 0 and go through. Yeah, and so basically, and this is basically you have, again, like last week we did the path point index. I mean, that basically will make a function get next and this will basically have an output, which will be a next material, which we will create material. And ultimately, this is going to basically there'll be more work here, but material list get, and it's going to be at the index. Now this is not the complete code, but this is what ultimately we're going to plop out. And again, this right here will make our lives much simpler. What we'll probably have to do is this next material. Well, actually, we'll do one more. Will be current and just an object reference. We'll set. Actually, we won't return next material. We can actually, let's delete these. We can instead set this. Hold on. So we can just keep this internally. So we can just call, this is not instant editable, because the other classes don't need to touch that. So we can basically make our lives easier, basically, with, instead of saying, hey, A or B, basically we'll set, again, the other thing we could do is, do a set and do set materials to make our lives easier. In our case, basically, is going to be just the for each loop, mesh list. Now, because we made these a list of static mesh actors, we can get static mesh. Get static mesh component. Set material, and then the current material. We can plug into there. And then we can then call get next material. So we set that up for our next loop through. Actually, no, not here. It would be under completed. Sorry. Again, we can go to the event graph. Won't need these guys. Set event. Sorry, set timer. Actually, let's just do set timer by function name in this case. Again, it's going to be set materials. Let's do another variable just so we have it. This is our change time. Oh, and I need to change this to a float. Yep. So you can. So if you've got a reference in the scene already, this is more than I realize. Okay. And is looping. So basically we've set up the timer here. Just to make sure. Let's see. Got materials, got next material. Let's finish this off just so that first thing that we're going to do again obviously is we're going to get this and increment it. And then this is going to be sorry, I want this to be greater than or equal to. All right, I could just use equal to. Again, what we want is the material list and its length. All right, I could say basically if it's equal to its length. Basically, this is just me being paranoid, saying something might be going wrong. This could be greater than that value, and if it is, I don't want to use that value either. So this is just paranoia on my part in terms of my coding. But if that's the case, what we're going to do is basically this is going to an if. Let me grab these guys. I mean, that's true, then basically we're going to go up and do a set. And then you do a reroute node. Because if it's false, we're just going to bypass that one. And then I'll pull this in. Then we'll finally set it. And make sure I plug that in. Make it compile. Let's go back to our scene. Here are the other objects. Let's get these lined up nicely. And let's move these up closer to the player. Okay. I'll unlock that for one moment. Content draw, we'll put B into the scene. I'll lock it for one moment right now so that we can go to the mesh list. Assign these guys as such. And then we're going to go into the material list and we'll set clay, grass, statue Statue glass. Do one more. Yeah, the wood marble. That should do it. And so now, if I go and I press, we'll save everything. Press play. You can see on this side, something didn't go happen. This is B. What happened? Let's rename. Should have. Why did the event by I'm just gonna go. Oh, I know what I didn't do. I didn't give a value down here. So let's just make this incidentable. And we'll just fix this in the editor itself. Here's B. Here we go. So here is, I'll do this 0.25. So we'll run through them really quickly. So go here and you can see both of them in the same action. So two ways to do the same thing. This is probably the more preferred way to do this. I'm probably going to go back. Now that I know what's going on, I will probably rebuild the. Don't be surprised to see your the lecture document, the assignment document altered to show, like, basically here's A, here's B. If you build this either way, I'll be happy. Do both, and I'll give you extra credit. And that's going to be state. That's I'm going to be. I'm going to go back to. I'm going to go back to the document, and so we can so that this way is valid to do. You know, I'll accept the second way. Do both for extra credit. I want you guys to think. I want to take a step back. I want you guys to take a look at what we're doing right now. And there's like bits and pieces of what we're doing right now are patterns. Like one of the patterns I want to point out would be is that, okay, we have an array and we have an integer related to that array. And we have a function that gets the next item in that array. And that basically this gets next material. I mean, like this right here where, you know, the material list, let me stream it a little bit better. I mean, the first thing is we increment that index. We ask if that index is greater than or equal to or greater than the length of the array, of that array. Because if that goes beyond it, we get basically exception. Basically, we're outside of the array. If that's true, we set it back to 0. Otherwise, we continue on with what we want to do. In this case, is to set the material based on that new value of the index. And I can bring this, make this. And this is a pattern. We saw this with our path runner last week. It's basically where we had a list of path points, we incremented it, and then this get set function. Now this looks more complicated than it really is. I'll tell you right now, this is like I think 6 lines, maybe 6 lines. If we were to write this in C# or C++, this would be much simpler, more straightforward. And that's one of the things is that Blueprint, there'll be things that as you go forward, you'll prefer to write things in C++ or C#, as opposed to in Blueprint. Your next class, we will be working with C++. And so one of the things that we'll be concerned about in that class is basically when are we using C++, when are we using Blueprint, how do we go back and forth between the two, and that's all, how to really effectively use the engine. There are times where you have to use C++. There are times where you don't have to use C++. So. Okay. I'm going to create a new class. It's going to be, I'm just going to call it Detonator. And essentially, for our purposes, it's basically a cube. This is going to be our platform. That's this. I'm just going to use wood oak just for the sake of argument right now, just so we have something. And then it's going to be, I'm going to get off this scene root, not the cube. I'm basically going to make, we're going to add a box collision. Again, we'll make the extent 50 by 50 by 50. We'll move up 25. 50. There you go, 55. So we have basically, essentially, this object right here. We'll compile. We'll click on, we'll call this the trigger, because that's really what it is. Compile one more time to get that change. We'll go to the event graph. And it's basically going to be, yeah, we delete all of this. Not drag. I don't want to move that. Let's do add event for trigger, collision, on begin overlap. We'll create an event dispatcher right here. This is going to be call explosion. Now we'll do this two ways. We're going to do as the level as it's intended using the level graph. But we will also create another version that's going to do what we need to do. I'll do another version as well. And this is basically going to call it. And just so that we know, we'll do print string call so just so we can know that this is working, and then we know that we're calling this. So let's go into our level. Let's put this down right here. For the sake of argument, let's unclick. Let's make this much bigger. Actually, this right over here. Yeah, I'll move this back. There you go. So you can see that it's calling the message. It's doing what we want so far. All right, to the level graph. save everything. Open level blueprint. And again, what we want to do with that is we want to create, this is, there we go. So add event for detonator, call add explosion. We won't need the tick, we won't need the begin play. In this case, basically, we are going to, let's go back. And let's just, I need a place to do something. I'm just going to take, I'm just going to add a cube. There we go. All right. So this cube is just going to be, hold on, F2. Explosion point. And this is a case basically for our purposes, like right now we can see it. I'm going to go and I'm going to, on the explosion point, the actor is going to be hidden in game. So basically it's going to act like it's just there to mark the point. So we're just going to use that explosion point. Let's actually call this explosion point level. Just call it for the level graph. Because we're going to do this a second way where we'll reference another actor. So now that I've got that, I can go back to the level graph, get, okay, the reference to it. In this case, we want to get actor transform. We're going to break the struct pin because we're not going to use scale. In this case, we're going to do spawn actor from class. Again, I'm going to break struct pin so I don't have scaling. And then select class. We should be able to do blueprint effect explosion. So we will compile, save everything, go back to the level, and off it goes. Where did it fall? Now I hear it. I just don't know where. I don't know where it's. Where? Let's go back to the level blueprint. Yeah, always spawning your collisions. Oh, it might. It's probably. Let's go back. The cube itself. Let's go look at. Yeah, right now it has default collisions. Basically, what we want to do is set this as no collision on that. That's what's going on. Let me save that. Let's just go back to default. That should have solved our problem. Where is it? So let's go to our started content. Articles. Okay. What I want was P explosion instead. So let's not spawn actor. Actually, what we want is spawn emitter at location. There, this is what we really wanted instead. Location, rotation. There we go. So there we are. In this case, we're getting, now why? There's a, we'll have to come back and look. Again, this is the case where we would want to, so now play sound at location. I'm just gonna do this quickly. So we'll talk quickly. Unreal uses what's called sound cues, and there's different versions of the sound cues as you go on. But basically, these are the raw explosion files, and this is a cue that basically is going to pick. Basically, it's going to pick between these two. So typically, when you're playing sounds, you're going to play a sound cue in Unreal, and this allows you to script the sound cue to do all sorts of different things. So now that we've done that, we can go back, press play, and there we go. Interesting. I'm gonna have to go back and look why there's a blueprint, but I don't know where it's spawning things in. It's just odd, but all right. Let's do this again. And let's do this without the level blueprint in play. So we're going to go back to our lab 5, and this is more akin to. Here's our blueprint class. I'm just gonna call it Boom Maker for the sake of argument right now. Again, we're basically is going to have the cube. Again, we'll make this 0.1, and then we'll go do clay beveled for the heck of it. Okay. Then we will then add the box collision. Okay, we'll move this up 55, and we'll make this 50 across the board. And again, rename this again to trigger. So far, so nothing has changed. What we will do is add a variable, which will be a, this is the, we'll call it explosion point, and this will be an actor. It'll be instance editable. So cool. So far, click on the trigger, go to our event graph. Again, the first thing will be, again, based on the trigger, collision, on begin overlap. Okay. First thing that we're going to do here is actually we're going to take get explosion point is valid. All right. Basically, we're asking here if this has been basically we're asking if this point has been defined. And that's going to go off to if And this is where you get to go print hey dummy level designer. And I'm here abusing my level designers. As someone who's trained as a level designer, I know that we need these types of messages. Not so brutal, but we do need these messages to, this is basically a basic error message. And we're not going to do anything based on that. If that's now with that in play, we can then just basically, we're going to spawn emitter at location. Explosion, play sound at location. And I'm going to make our life, no, and then basically what we can then do is explosion point, get character location. We don't need to worry about rotate. I mean, I could have done the transform and done all of that. I'm just going to do this for our purposes right now. Put that out, plug that in. So I'm going to do all that work instead. Okay, now that I've got this in place, I'll save everything. I'll go into the scene. Scale it by 3 just so that we're consistent here. Press play, and I'll go, and you can see, hey, because I didn't assign that, it's now giving me the error message. So, hey, think about, there's something to think about. Hey, you can validate things. You can ask if something. So in Unreal, if a value is not assigned to something, you get back what's called the none, which is basically a null in C++, in C#, in Java. That would be a null reference, effectively. That's the type that you would get back would be null. In Unreal, in terms of the editor, that ends up being none. Which is how this is the engine, how the engine works basically. I'm gonna grab. Let's go back. Copy, paste, and rename you. BP class. And then I'm gonna move you over here. And then I'm just going to go here, and this will be the level, the BB class. And then you'll see I'll go in. Why is it not playing the sound? Let's go look at the. Oh, and I did not select the sound. There you go. And I'll pick collapse cube for. Why not? So you can see that. And it'd be helpful if I actually select the queue and compile, save everything. There you go. Again, 2 ways to do the same thing. This again, B would be preferred because that's integrated all within one object. You know that this is going to do, and basically you do is basically because you don't know, you want to call something that's in the level, but you don't know what you're going to do or who you're going to call. B, you're going to create because you know what you want to do. You just don't know where, for example. So 2 ways to do the same thing. It's useful to know that. Again, A is for helping building things for your designers to use. This is, hey, I build out objects that the designers can use that can interact with other things, with other objects. Now, am I interacting with the, like, is it level specific, or can I just make this object specific? More times you're going to go B than you're going to go A, because A is very specific. Is very specific. You can use that in a level. I can copy. In theory, let's go back. I can copy these two objects. Grab these two objects. And let's move these over. And you can see that it's got, this is class 2, and you can see, let me make this a little bit bigger. You can see that it's referring to the other one already. So I can literally copy and paste those objects, gave me references, and you can see that if I were to have to do that with the level print, I'd have to go back and literally script it. So there's A exists because legacy reasons. Your level designers have the level blueprints, and there's time and place for that. B is more where we are going with this engine. We're now saying, hey, here's the object, sign stuff to it in the editor. And this is more how you would work in Unity, basically. A is traditional Unreal, literally the B the way that we're doing with B, where you're signing, that's because Unity came along. I can tell you that. That's a legacy. Unreal looked at, literally Unreal Engine 4 is interesting because it looked at literally at everything that Unity was doing and said, hey, that's cool, that's cool, that's cool, that's cool. We can do that too. And implemented things that you would do in Unity, that made Unity easier to use in some cases. And it was like, yoink. I know the people on Unreal do not prefer me saying that, but that's, as a user of multiple versions of this engine and multiple engines, that's how it felt at the time. It literally took of like everything that was that Unity did reasonably well, and it's like, oh, we could do that too. Here, feature, have fun, everyone. So, are there any other questions for me? Any questions at all? Am I going too fast? No. Okay. Okay. I'm going to stop the recording right here. I need to not be in play mode.